Hello everyone, my name is Benjamin, and in this video I will be presenting a summary of the key concepts that I learned in the course Engineering Ethics and Sustainable Development. So engineering is not just about building machines and technologies. It's also about understanding the responsibilities that engineers have towards the society, the environment and the future generations. So through this course we explored various important topics such as ethical responsibilities of engineers, sustainable development, renewable energies, etc. In this video, I will be briefly talking about modules 1, 2, 3, and 4, and also the key takeaways from these modules, and also reflect on the lessons that I learned and how it can influence my future as an engineer. So, the first module introduces the fundamental concepts of engineering ethics. Now, engineering ethics refers to the moral principles and professional standards that guide engineers in their work and decision making. Engineers often face situations where this decision can affect public safety, environmental stability, and social welfare. Therefore, ethical responsibility becomes extremely important. Now, some of the core principles and engineering ethics include honesty and integrity, responsibility towards public safety, accountability for professional decisions, respect for environmental sustainability. One of the key ideas discussed in this module was that engineering failures are often not only technical failures but also ethical failures. So historical disasters have shown that ignoring safety standards, neglecting risk assessment, or prioritizing profit over safety can lead to catastrophic consequences. Therefore, engineers must always prioritize welfare, safety, and environmental protection while making technical decisions. Now, moving on to Module 2. Module 2 focuses on the environmental ethics and sustainable development. Now, sustainable development means meeting the needs of the present without compromising the ability of future generations to meet their own needs. Now, this concept emphasizes the balance between three important pillars: economic development, environmental protection, and social well-being. Now, rapid industrialization and technical development have brought great benefits to society. However, they have also caused serious environmental problems such as air pollution, water pollution, deforestation, and climate change. Now, engineers play a crucial role in solving these problems, and that's done by designing technologies that are efficient, environmentally friendly, and also sustainable. This module also highlighted the importance of ethical decision making in environmental management, ensuring that development projects do not harm ecosystems or vulnerable communities. Now, moving on to Module 3. Module 3 expanded on the idea of sustainable resources management and environmental responsibility. Natural resources such as forest, water, minerals, fossil fuels are limited and unsustainable. Now, exploitation can lead to long-term ecological damage. Therefore, engineers must promote practices such as efficient resource utilization, waste reduction, recycling and reuse, pollution prevention, etc. This module also discussed water management and environmental conservation strategies, now which are particularly important in regions facing water scarcity and ecological degradation. Another important topic covered was the role of engineers in promoting green technologies and environmentally responsible infrastructure. Now, by adopting sustainable engineering practices, engineers can help reduce environmental impacts while supporting economic growth and societal development. Module 4 focuses on renewable energy, climate change, and environmental policies. One of the most important solutions to global environmental challenges is the transition from fossil fuels to renewable energy sources. Now, some major renewable energy sources are solar energy, wind energy, hydropower, biomass energy, emerging sources like tidal energy and green hydrogen. Now, solar photovoltaic systems convert sunlight directly into electricity, while wind turbines generate power using wind energy. And hydropower uses flowing water to produce electricity, and biomass energy is created from organic waste materials. Now, one of the examples of this solar energy, you can see it in Cochin International Airport, which is also one of the first airports to have a fully sustainable power source. It's self sufficient and it doesn't really rely on the grid, not that much. However, renewable energy also presents challenges such as intermittency, high initial costs, and land use conflicts. Now, despite these challenges, renewable energy offers enormous opportunities for reducing greenhouse gas emissions and achieving sustainable development. Now, this module also discussed climate change, which is primarily caused by increasing concentration of greenhouse gases such as carbon dioxide and methane. Now, climate change has serious impacts on both natural and human systems, including rising sea levels, melting glaciers, extreme weather events, and agricultural disruptions, urban flooding, etc. For example, events like the Kerala floods highlights how climate-related disasters can affect infrastructure, livelihoods, and ecosystems. Engineers play a crucial role in addressing climate change through renewable energy source systems, energy efficient technologies, climate resilient infrastructure, smart grids, and sustainable urban designs. Now, the module also highlighted several environmental policies and global agreements such as the Environmental Protection Act of India, Paris Climate Agreement, and the Montreal Protocol. Now, these policies help regulate pollution, protect the ecosystem, and guide global efforts towards sustainable development. Key takeaways from this course is, first of all, engineering is not only a technical profession but also a social responsibility. The second is that sustainable development must guide technological innovation to ensure that economic process does not harm the environment. The third one is that renewable energy and green technologies are essential for addressing climate change and building a sustainable future. Finally, engineers must always act with integrity, responsibility, and ethical awareness in their professional work. Now, my reflection to this would be that personally, this course helped me understand that the role of engineer goes far beyond technical designs. Engineers have the power to influence society, shape technology process, and protect the environment. As a future engineer, I realize the importance of considering the long-term social and environmental impacts of engineering decisions. Now, as a future engineer, I realize the importance of considering the long-term and social environmental impacts of engineering decisions. Engineering decisions. This course has strengthened my commitment to responsible engineering practices and sustainable innovation. Based on the knowledge gained from this course, I believe engineers should actively work toward promoting renewable energy technologies, designing environmentally sustainable infrastructure, supporting policies that protect ecosystems and natural resources, developing innovative solutions to combat climate change, etc. About by combining ethical responsibility with technological innovation, engineers can help build a more sustainable and equitable world for the future. In conclusion, in conclusion, engineering ethics and sustainable development are essential for ensuring that technological progress benefits both the society and the environment. Now, by applying ethical principles and sustainable practices, engineers can play a key role in addressing global challenges and creating a better future. Thank you.